This is Varanasi. For Hindus, it's one of the holiest sites in all of India. Part of what makes it so special is the orientation of its sacred river as it flows past the city.
This is the one place on the Ganges where you can bathe in the river on this shore and you can see the sunrise on the eastern shore. It's the only place where the Ganges turns around to the north, so you can do that.
When the sun rises tomorrow, a truly extraordinary phenomenon will take place, a total eclipse of the sun. It's an auspicious occasion for a place that ancient Hindus knew as the solar city.
Science is different to all the other systems of thought, the belief systems that have been practiced in this city for millennia, because you don't need faith in it, you can check that it works. So, for example, I can tell you that tomorrow morning at precisely 6:24 a.m. the moon will cover the face of the sun and there will be a total solar eclipse. I could tell you that in 2904 there will be 5 solar eclipses on the Earth. And I could tell you that on July 16, 2186, there will be the longest solar eclipse for 5,000 years, 7 minutes.
However, as anyone who's been to India in June, July will know, the climate is not entirely predictable, right? It's a cloudy, rainy place. And so we took a huge gamble.
It's 5:28, so that's time of first contact, and you can't see the disk of the sun at the moment. It's obscured by low cloud. The edge of the moon is at this point just beginning to touch the disk of the sun. You can see the sun emerging through the clouds, see the disk. Oh, and you can see the moon. Can you see the moon on the top? Oh yeah. It just vanished. You can see the limb of the moon there. Absolutely fantastic. Yeah. See the sun. You can see the celestial mechanics, the clockwork of the solar system at work. The alignment is absolutely perfect. Oh, there. Look at that. You know, if you ever needed convincing that we live in a solar system, that we are on a ball of rock orbiting around the sun with other balls of rock, then look at that. That's the solar system coming down and grabbing you by the throat.
It's one of the most remarkable things I've ever experienced, because this piece of rock went across the face of the sun on time, to the second, exactly as had been predicted using Newton's laws. And I got this feeling that I'm on a piece of rock in space. And it was this totally unexpected feeling.
Look at that!
If you're interested in astronomy and SETI, the search for extraterrestrial intelligence, you know the name Frank Drake. And when you meet someone like that, one of your heroes, it's a special moment. And he did not disappoint.
So if I'd have asked you back in the 1960s, by the 21st century, Do you expect to have seen a signal? What would you have said?
I would have said, yes, I expect to succeed, because we were doing a lot of searching then.
Does that make you disappointed?
I'm disappointed, yes, but not surprised. What we've learned over the years is that the searching has to be much more comprehensive than we realized 50 years ago. But we know it's still doable. It just takes much more time than we imagined. Let me show you something. This is an orchid, a very peculiar and beautiful orchid. It's very fragrant, which actually only blooms 2 days a year. If you had been here 2 days ago, you wouldn't have seen this orchid, and you might have thought that this plant never blooms. Well, so it is with SETI. We've learned that we must search over and over and over through the years till we are in the right place at the right time to make the discovery.
What are they called?
This is called a stanhopea. It has hope in its name, and we have hope that someday we'll be in the right place at the right time in SETI.
Frank Drake makes the argument that if there are civilizations out there, then you might imagine that the radio waves that they send out are passing through the galaxy. And so they would be passing through this room now. So if only you had a sensitive enough detector, then maybe you could pick up the signals. And he's right. The point he's making it as a scientist is that the only way you're going to know is to look. And he doesn't think we've looked closely enough. And I agree with him. But Frank wasn't content just to hang on the line, waiting for ET's call. In 1961, he devised what remains a useful scientific framework for considering how likely it is that we share the galaxy with others. The Drake equation has become famous because it gives us a tool to continue the search. It dares us to answer a series of provocative scientific questions. And on the left-hand side, there's the number we want to measure, the number of intelligent civilizations in the galaxy that we can communicate with. And then there's this group of terms that really ask questions about ourselves. How likely is it for life to arise on a planet? How special is the Earth? How special is the Sun? How special is the solar system? How special is intelligence? And then there's this last term, L, which perhaps speaks to us most profoundly of all, the lifetime of intelligent civilizations. Do civilizations live for a long or short time? And if it's short, what is it that destroys them? Is it a natural disaster? We do, after all, live in a violent universe. Or are they condemned to destroy themselves? When Frank first thought about it, sort of 50 years ago, for example, the number of planets around distant stars, how likely is it? What's the probability that a star will have planets around it? We didn't know. We hadn't detected any. It's not till the 1990s that we have the evidence for planets around different distant stars. Now we have dedicated missions to go and look for them. And these missions are revealing a universe full of possibilities. And in the constellation of Pegasus, around a sun-like star, there's a planet called Osiris. It's way closer to its parent star than Mercury is to our sun, but it's a massive gas giant, a hot Jupiter. And by measuring the light that shines through its atmosphere, we found that the atmosphere is full of hydrogen and methane and water. And just 24 light years away in the constellation of Scorpius, there's a small rocky world, one of the most Earth-like worlds we know. It orbits around a red dwarf star, which is one of 3 stars in the system. A planet with 3 suns in the sky. I think most people thought that we would be back to the moon quite soon. Actually, it's been 50 years and we haven't gone back. But now we're trying to reacquire those skills because we want to go further. So the next step is Mars. Mars is in our backyard. It's the most Earth-like place in the solar system other than the Earth, but by a long way. It's almost habitable. So I think if there is going to be a new frontier physically that we're going to explore, then there is no choice. It has to be Mars. NASA is developing machines for mining and building on other worlds. The Moon is seen as a stepping stone to Mars. One day, robots will mine the lunar surface to build habitats for human settlers.
One stick drives one side of the wheels and the other stick drives the other side of the wheel.
Robotics engineer AJ Nick is letting me take one out for a spin.
So we turn on this button and you can go ahead and raise this arm over here and keep driving.
You know, there's a real feeling of stability there, and you're confident I can't break this.
I have done way worse to this robot.
I suppose the obvious question is, if you want to mine this, why don't you just get a shovel and dig it up? Why is the robot so complicated?
The first problem is we're trying to make everything as lightweight as possible, fit inside of a rocket. Then you get there on the lunar surface and you have reduced gravity once you get there. So now the thing that was already really light, because you had to make it light to fit in the rocket, is even lighter while it's there on Earth. Since we don't have a lot of weight, it's very difficult.
AJ and his team have come up with a unique design that will allow their robots to work in the Moon's weak gravity. So now I'm digging. The scooping drums at either end rotate in opposite directions. This has the effect of pinning the robot to the ground, allowing it to dig without floating off into space.
As one drum on the front is digging, the other drum is rotating the opposite direction from the other drum. And so that allows the excavation forces to be canceled as it's digging.
This is the only vehicle in the world that can dig more than its own weight. If I took it into this trench the wrong way,
right,
it may well fall over. Can I do that?
Yeah.
Oh, yep. Unlike other planetary rovers, these robots are meant to be robust, designed to get themselves out of problems, even if they're flipped upside down. But it's really easy to drive and really manoeuvrable and really powerful, and it does seem like you can get out of a lot of trouble. Once the lunar dirt has been dug up, it needs to be transformed into a building material.
Show you some materials here.
Senior technologist Robert Muller has been sintering the lunar dust, heating it until it solidifies.
So the result, a well-sintered regolith, is this. And that's essentially turning crushed rock back into solid rock.
That's really quite heavy, actually. That feels quite dense. So that is just this material in an oven, essentially.
That's right.
By mixing the regolith with plastic, Rob can create something far more versatile, a material which can be used in a 3D printer.
And we use the big robot arm, and we have a print head on it, and then we're able to make objects like this. This is a blast deflection wall, or this is an ogive dome. It could be used for the roof of a habitat when it gets really big. And in fact, it's quite strong. If you look down at it, it's very strong. You can kick it all day long and it won't break.
That's quite... So that is built by that robot?
Yes.
Using essentially the regolith that you would find on the Moon?
That's correct. So you never bring any materials from Earth.
Yeah.
You go mine them on the Moon, and then you build whatever you need to create your local moon base out of local materials. All you have to bring is the robot.
Everything is there, is the point.
Everything is there. The only two things that are missing are technologies and imagination. If we can put those two things together and harness the materials and the energy we have in space, we have all the resources in space we need. We just need to be clever enough to learn how to use them.
Floating in the Sea of Cortez off the coast of Mexico is the research vessel Atlantis, the mothership for the exploration of one of the most alien worlds we know. But it's an alien world on our planet. The Atlantis is the launch vessel for Alvin, one of the world's most rugged submarines. Built like a spacecraft, it's designed to explore the deepest depths of the ocean. And I'm lucky enough to have hitched a ride down to the sea floor, 2 kilometres beneath the surface.
It's honestly got to be the closest thing to going into space that you can do. And given that I'm not going to go into space anytime soon, I think this is the next best thing. See you in 8 hours.
Starboard time!
The parallels to spaceflight are obvious. As the tiny capsule descends, we're leaving the familiar world of the surface of our planet and entering a strange, hostile world.
240 reading, 400 meters.
If anything goes wrong, we will be completely on our own.
It's very rare that you get to do something so challenging and so alien. To be taken to that environment in the very deep ocean, it's strange and silent and unusual. And it's tiny as well. So there's 3 people crammed into this little titanium ball, which kind of creaks a bit as it goes down.
Creeping's never good.
Looks like the atmosphere.
At the Earth's surface, we're used to 1 atmosphere of pressure.
353.
As we descend, the pressure increases by another atmosphere every 10 metres, and it soon adds up.
Mark, you're gonna have to repeat that if you want to be
So we're just approaching 1 kilometre deep. The pressure outside there is now, 100 atmospheres? That's higher than the atmospheric pressure on the surface of Venus. Without knowing, if you were asked the question, could life exist down here? 100 atmospheres, cold, dark, no sign of sunlight at all, it's pitch black there, you would say no. Well, I would say no. For me, the fascinating thing about finding life down here is that the conditions on the deep ocean floor are more similar in many ways to the conditions on worlds hundreds of millions of kilometres away out there in the solar system than they are to the conditions just 2 kilometres above my head on the Earth's surface. You know, it's incredibly dark, there's no sunlight, there's a brutal mixture of hot and cold water and just, well, rock and minerals. So if life can not only survive but even flourish in these conditions, then you've got to feel that it's much more likely that life can also survive and flourish out there in the solar system.
One of the main benefits, I think, in looking at life in extreme environments on Earth, so-called extremophiles, is that you get a wider view of what life is and what chemical elements or compounds it produces. And that is useful because really, if you think about life subsurface on Mars, for example, if it exists, we really don't know how that life would behave. We tend to think of exploration as walking across new terrain and planting a flag, like the polar explorers of old. But it doesn't have to be that. It can also be intellectual. And actually, for most of history, our exploration of the universe beyond Earth has not been physical. It's been looking up at the stars.
These are the Atlas Mountains in North Africa. According to Roman legend, they held the heavens above the earth. And they are one of the finest places to come to view the stars. From a place like this, it's easy to appreciate the profound effect that the night sky would have had on our ancestors.
You know, from a modern perspective, astronomy can seem remote and arcane because we've lost our connection with the night sky. From a city, you just don't see a sky look anything like this. From the darkness of the Atlas Mountains, it's really, truly majestic.
So for our ancestors, the connection with the night sky would have been incredibly intimate. They looked into the skies to understand their place in creation, and the movement of the stars told them one thing: they were at the centre of the universe.
Up there is Polaris, the North Star, and it's almost exactly aligned with the Earth's spin axis, which means that as the Earth rotates, all the stars rotate through the sky around that point. So it looks for all the world as if the Earth is at the centre of the universe and the stars rotate around it. And that's, of course, what the ancients thought for thousands of years. And why not? Because it's obvious, but wrong.
To understand the Earth's real position in the solar system, we need to look at the one set of bodies that doesn't behave as predictably as the stars.
Well, understanding the retrograde motion of Mars didn't come easy. That's why it took over 2,000 years to work out. But I'm going to explain it using a stick and some rocks. The key thing is that the Earth is not at the centre of the solar system. The Sun is. And the Earth and Mars go around it in almost circular orbits. So when Mars is viewed from the Earth, then it's seen on the sky. In fact, on the constellations of the zodiac. So as Mars orbits around and the Earth orbits around, then from that position, Mars will look like it's there on the sky. Mars moves and the Earth moves in that position, and Mars moves that direction across the sky, and again in that position Mars will be here. So you see it's moving in a straight line across the sky. But what happens when the Earth overtakes Mars? Then look at the line of sight. Mars has moved back to there. It's reversed its direction, and it continues to do that until the Earth gets round to somewhere like there, and Mars is here. And then you see the line of sight means that it started moving that way again. So Mars has executed that strange looping motion on the sky because the Earth overtook Mars on the inside. And that's why the retrograde motion happens. Simple.
Understanding the retrograde loops was one of the major achievements of early astronomy. It created the concept of the solar system and allowed us to build the first accurate maps of the planets and their orbits around the Sun.